Good morning, students. In today's is going to be the 18th session, and the topic which we are going to discuss is going to be under coordination chemistry. In today's class, we will be discussing regarding the structural isomerism in complexes. So, the class we are going to deal structural isomerism in complexes. There are two main forms of isomerism exhibited by coordination compounds. That is, coordination compound mainly exhibit two forms of isomerism, and they are structural isomerism, stereoisomerism, or stereoisomerism is even called as spatial isomerism. But in today's class, we are going to discuss regarding the structural isomerism. Structural isomerism is again going to be of four types. Structural isomerism can be again of four types. They are ionization isomerism, coordination isomerism, linkage isomerism, hydrate isomerism. Structural isomerism again is of four types. They are ionization isomerism, coordination isomerism, linkage isomerism, hydrate isomerism. In ionization isomerism, first let us discuss ionization isomerism. Compounds which give different ions in solution, although they have same composition, are called ionization isomerism. That is, here the composition of the compound is going to remain the same. The composition is going to remain the same, but in solution they are going to give different ions. For example, if we are going to consider pentamine sulfato cobalt bromide and pentamine bromo cobalt sulfate, both have the same composition, the color of this compound is going to be red, the color of this compound is going to be red violet. But when this is taken in solution, when they are going to be taken in solution, what happens is, in solution, this compound is going to give me bromide ions. And how do I know I get bromide ions? This, when it is going to be tested, when the solution is going to be tested with silver nitrate, we are going to get a pale yellow precipitate. But students, in this case, if this compound is going to be added in solution, it is going to give me sulfate ions. It is going to give me sulfate ions. So, such compounds which have the same composition but in solution they are going to give different ions are called as ionization isomerism. So, here is going to be another example, and in this one, where nitrate ions are there in solution, and here in this one bromide ions are going to be in the solution. In coordination isomerism, this type of isomerism arises from the interchange of ligands between cationic and anionic entities. Coordination isomerism arises from the interchange of ligands. When there is going to be an interchange of ligands between the cationic and the anionic entities of different metal ions in the complex, then coordination isomerism is going to be exhibited. For example, if I just go on to consider hexamine cobalt cation and hexacyanochromium, this is going to be one complex, and another complex is going to be hexamine chromium and hexacyano-cobalt. If we are going to consider these two complexes, they both have same composition. But what do we observe is, in this complex, if we are going to consider this hexamine cobalt and hexacyanochromium, what do we observe is, in this case, ammonia ligand is attached to cobalt 3 plus ion. In this case, ammonia molecules are attached to cobalt 3 plus ion, whereas cyano groups are attached to chromium 3 plus. But in this complex, see, the composition is going to remain the same, but there is going to be an interchange. Now here ammonia molecules are attached to chromium ion and cyano group is been attached to the cobalt ion. Here ammonia molecules are attached to chromium ion and cyano groups are attached to cobalt. Such complexes wherein they have got same composition but there is only an interchange of ligands between the cationic and anionic entities are called as coordination isomerism. Coming to linkage isomerism. This isomerism arises in coordination compounds which have got ambidentate ligand. So linkage isomerism arises in coordination compounds containing ambidentate ligand. An ambidentate ligand is one which can donate electrons from two type of atoms of the same group. For example, in case of NO2, nitrogen can donate a lone pair of electrons or oxygen can donate a lone pair of electrons. So, such an isomerism which arises in coordinate compounds with same composition but the linkage is going to be different. In this case, nitrogen is linked to the central metal ion cobalt and in this case, oxygen is attached to the central metal ion. So, such an isomers which have same composition but they differ only in the connection of the ligand to the central metal ion are called as linkage isomerism. And the last one is hydrate isomerism. In hydrate isomerism, compounds have same molecular composition. Here, the compounds will have same molecular composition but differ in the number of water molecules present as ligands. Here, the composition will remain the same but the number of water molecules which are present can be either as ligands or as hydrate water molecules. Such isomers or such compounds are called as hydrate isomerism. For example, if you are going to consider this, here the composition, if you see the three complexes, all the three complexes have the same composition but in this case, what do we observe is there are 4 water molecules are attached to chromium as a ligand and I have got 2 water molecules as water of crystallization or hydration. That is totally there are 6 water molecules, 4 are attached to chromium as a ligand and 2 as hydrate. Again, in this complex which is going to be blue-green color, what do we observe is 5 water molecules are attached to chromium and only 1 is going to be present as hydrated molecule and this is going to be blue-green in color. Another complex is going to be here is hexaaqua chromium 3 chloride. So in this case what do we observe? All the 6 water molecules are present as a ligand. They are attached to the chromium as a ligand. All the 6 water molecules are attached to chromium as a ligand and this appears to be violet in color. So such compounds which have same molecular composition but differ in the water molecule present as a ligand are called as hydrate isomers. Okay, thank you.